Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video I'm going to show you guys how to classify handwritten digits as numbers 0 to 9 using convolutional neural networks, or CNN for short. Now I'm currently on Google's website called colab.research.google.com because it makes it really easy to get started programming in Python. So you don't need to install Python onto your computer. You can just go to this website and log into your Google account and immediately get started programming in Python. So let's go ahead and start writing our program to classify handwritten digits as numbers 0 to 9. So first thing we need to do is go over here to File and then click New Python 3 Notebook. And it's going to open up a new tab in a new cell for us where we can immediately start writing our Python program. So I'm going to put a description here of what the program does. So this program uses convolutional neural networks to classify handwritten digits as numbers 0 to 9, and I'm going to put CNN in parentheses here. And also I want this to be shown on the screen here, so I'm going to bring it on down and make it a comment and move it over like so, and so it makes it look a lot better here. So let's go ahead and create a new cell by clicking that code button, and inside this cell we're going to import the libraries. So we're going to import Keras, Matplotlib, and NumPy. So from keras.models we are going to import sequential, which allows us to build the architecture for our neural network. And then from keras.layers we're going to import dense, conv2d, and flatten. And this will allow us to create layers for our model or for our neural network. And then from keras.datasets, we're going to import the manist dataset, which contains all of our images, which are the handwritten images that are 28 by 28 pixel images that we're going to use in this program. And then from keras.utils, we're going to import to_categorical, which allows us to do some encoding on the data. And next we're going to import matplotlib.pyplot as plt, and we're going to import numpy as np. Alright, so let me go ahead and run this by clicking this button to the left, and hopefully there are no errors. And it looks good here, so I'm going to go here and I'm going to exit this label, and then we're going to create a new cell, and inside this cell I'm going to load the data and split it into a train set and test sets. Okay, so to do that I'm going to create two tuples, right? So one tuple is going to contain the train data set, so we're going to create variables x_train and y_train. So x_train will contain the training images and y_train will contain the training label. All right, or labels. And then here will be our test data set, so it will contain x_test and y_test, where x_test contains the images to test on and y_test contains the labels to test on. All right, and then we're going to set it equal to manist.load_data function, and let's go ahead and run this. All right, so it looks like there are no errors, and of course I just ran it by clicking that button here to the left. So let's go ahead and create a new cell, and we're going to start exploring the data. So I want to get the image shape, and remember all of the images are in the X data set. So that's the data set that contains x_train and x_test. So we're going to print the shape of those. So print x_train.shape, and then print x_test.shape. All right, so let's go ahead and run this. And what we see is for the x_train data shape, we get back 60,000 rows of images that are 28 by 28 pixels. And then for the x_test dataset, we get 10,000 rows of 28 by 28 pixel images. Okay, so let's go ahead and create a new cell here. And what we're going to do now, we'll bring that on up. We're going to take a look at the first image, which is located at index 0. And we're going to look at the image in the training data set. Okay, so to do that, just type x underscore train, and then we want position 0. And let's go ahead and run this. And so we get back a NumPy array, which shows the image as a series of pixel values, and each pixel value will be a number between 0 and 255, so there'd be 256 possible values. And what we can see, we can kind of see what the image looks like. It almost looks like an S here, so we can see the 0 padding, I guess, around it. That it's not really padding, it's just part of the image. So it looks like an S, but I know we're looking at the MNIST data set, which only contains images of numbers. So the most likely number that it is the number 5, because that's the number most similar to the letter S. But we can test this by looking at the training label. So let's go ahead and create a new cell, and let's print the image label. All right, so to do that, I just type y underscore train, and then I get the label at position 0. And we can see that it is indeed the number 5 that we were looking at before. But let's actually look at it as a picture. So here we're going to show the image as a picture. And to do that, just type plt.im_show, and then we want the xtrain data set. We want the first image, so that's at position 0. And so let's go ahead and run this. And now we get back a 28 by 28 image of the picture that we were looking at. And like I said, it kind of looks like an S from the array, but we can see here it still does look like an S, but we know for sure it's the number 5. All right. So now let's create a new cell where we're going to process the data, and we're going to reshape the data to fit the model. So here I put reshape the data to fit the model. And so we're going to reshape the X data set. And again, that's the data set that contains X underscore train and X underscore test. So X underscore train is going to be equal to X underscore train dot reshape. And it's going to become, it's going to have 60,000 rows and 28 by 28 pixels, but this time it's going to have a depth of 1. So depth of 1 is the grayscale. All right, so it's going to tell how gray it can be. So it's going to be basically values that show a color from white to black. All right, and we need to do the same thing for our testing data set. So X underscore test is going to be equal to X underscore test dot reshape, and it has 10,000 rows. It's got 10,000 rows of 28 by 28 pixels with a depth equal to 1 as well. So let's go ahead and run this. Hopefully there are no errors, and it looks like everything is good. So let's create a new cell, and this time we need to process the Y data set, which is the data set that contains Y underscore train and Y underscore test. So we're going to do something called one hot encoding. All right, and I'm going to put that together here. And what that basically means is that we're going to encode this target data. So we're going to convert the labels into a set of 10 numbers to input into the neural network. So I'm going to create some new variables. I'm going to create one and call it y underscore train underscore one underscore hot. And I'm going to create another one later on, but we're going to set this equal to 2 underscore categorical. And we're going to input the training data set. All right, and then we need to do the same thing for the testing data set. So I'm going to create a variable called y underscore train, or test actually, underscore one underscore hot, and set it equal to 2 underscore categorical, and we're going to use y underscore test here. And then I want to print the new label. So before we saw that the label was 5, so let's see what the label looks like now when we print y underscore train underscore 1 underscore hot at that same position. All right, so let's go ahead and run this. And now you can see that we get back a set of 10 digits. What we're really looking at is we're looking at the label. So the label was 5, so we're going to see a value of 1 at index equal to 5, and all the rest are going to be zeros. So let's test this. So here we have 0. Let me see here. We have, move this out of the way. Okay, we have 0 here, so that's index 0. We have 0 here, that's index 1. 0 here, that's index 2. 0 here is index 3. 0 here is index 4, and then we see our 1 at index equal to 5. So we know that the label is 5. All right. Okay, so now let's go ahead and build our model. So I'm going to create a new cell here. So we're going to build the CNN model. All right. So in order to do this, I'm just going to create a variable called model and set it equal to sequential. Again, this allows us to create the architecture. And then we're going to start adding layers to the model. So here I put add model layers. And to do that, we're just going to say model.add, and then we tell it the layers that we want it to add. So we're going to add conv2d, which is our convolution layer to extract features from the input image and create, we're going to create 64 channels. So I'm going to put 64 here for the number of channels that we're going to create, and then we're going to give it a kernel size. Okay, so it's going to be a 3x3 kernel, and then we give it an activation record equal to ReLU, which stands for rectifier linear unit. And then because this is the first layer, we need to give it a input shape, and the input shape will be the images that we're putting in, which are 28 by 28 images with a depth of 1. Okay, and next let's add to our model, let's add another convolution layer, so conv2d, but this time it's going to have 32 channels, and the kernel size will still be the same, so I'm going to set it equal to 3. It's going to be a 3x3 kernel, and then it's going to have the activation record equal to ReLU, and we don't need to put the input size because this is not the first layer. All right, next we're going to add a flatten layer. So this right here will take the images and flatten them, so it's going to turn them into a one-dimensional array or one-dimensional vector, and this way it can connect to the neural network or pass in values to the neural network. So this is going to be the last layer here. It's going to be a layer that contains 10 neurons, and I chose the number 10 because we have 10 different labels, right? Okay, and this layer is going to use the activation function called softmax. All right, so let's go ahead and run this. Hopefully we have no errors. Okay, so everything looks good here. I'm going to create a new cell, and what we're going to do here is compile the model. So to do that, I just type model.compile, and then we need to give it an optimizer. So the optimizer is going to be Atom, and then I need to give it a loss function. So I'm going to use categorical cross entropy. So that loss function is used for classes that are greater than 2. So like what we have here, we have 10 different classes, and then I want to give it some metrics. So we're going to check out the accuracy of the model. Okay, so let's go ahead and run this. Hopefully there's no errors. Okay, look like everything compiled fine. I'm going to create a new cell here, and here what we're going to do is train the model. Okay, so to do that, first I'm going to create a variable called hist, and I'm going to set it equal to model.fit. So fit is another name for train, and inside here we need to tell it the data that we want to train on. So x underscore train and y underscore train, and then we need to tell it, well actually it's going to be not y underscore train, it's going to be y underscore train underscore one underscore hot, right? Because that's the encoded data. So if we were to put y underscore train here, it would give us an error because that data is not already prepared to go into this model to be trained upon. Okay, so next I'm going to input the validation data, which will be our test set. And so it's going to be x underscore test and y underscore test underscore one underscore hot. And then I need to tell it the epochs. So the epochs is just the number of iterations when an entire data set is passed forward and backward through the neural network. So epochs is going to equal 3. And then another option is to give it the batch size. If we don't give it a batch size, then the default is 32. So let's go ahead and run this. Hopefully there are no errors. If there aren't, then it will take some time to train, and I will pause the video and come back when it's done. So let's go ahead and run this. All right, so it looks like it's training. There are no errors here. So I will get back with you guys as soon as this model is done training. Okay, and we are back. So the model's done training now. So let's see how well it did. So I'm going to take this here and scroll on over. Look like it has a 98.59% accuracy rate on the training data and 97.68% accuracy rate on the testing data. So let's visualize this accuracy. So I'm going to create a new cell here, and here we're going to put visualize the model's accuracy. Okay, so to do that, we're going to use plt.plot and hist.history, and we're going to get the accuracy on the training data, and then basically the same thing, plt.plot history or hist.history, but this time we want the accuracy on the test data. So here I put test, or we can say val for validation. So val accuracy. Okay, and then I'm going to give the plot a title. So we're going to call it model accuracy, and I need to put all of that in quotes. So model accuracy. All right, and then I want to give the y-axis a label. So y label is going to be accuracy, and then I want to do the same thing for the x-axis, give that a label. So it's going to be epochs or epoch, and then I want to give this plot a legend. So it's going to show the train for training data set and val for the validation data set. Okay, and it's going to be located in the upper left. All right, and then I want to show this plot. All right, so that looks like that should be it. So let me go ahead and run this. Oh, like I got a few errors here. Let's see. History object. Oh, because I misspelled history. I called it hostory. So let's change that to an I and let's run this. And now we get the a graph of the accuracy. Okay. Alrighty. So let's go ahead and create a new cell. And here we want to show predictions as probabilities, because the neural network gives us back probabilities. Okay, and we'll do this for the first 4 images in the test set. Okay, so I'm gonna create a variable called predictions and set it equal to model.predict. And inside here, we're going to tell it what we want to predict. So we want to predict on the x underscore test data, and we want the first 4 images. All right, and then I'm going to print out this prediction. So let's run this and let's take a look. So it looks pretty crazy, right? So we can see 1 prediction here, 2 predictions here, 3, and then 4. So that's going to be for each of the images. These are the 4 I guess, groups. So each of these are for the image, and there's a probability of it being a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 digit, and the probabilities are here. So the probability of it being a digit for one of the images is here. The probability of it being a 1 for the image is here, and the probability of it being a 2 for the image is here, and so on and so forth for that one specific image. And then of course this would show the probability of 0 for another image, or for the second image. Okay, so that's what we're looking at here, and it's actually really hard to read. If I were to look at this here, the first image is most likely here. So what is that? Let's see, 9, 8. So it looks like it's a 7. It looks like that's going to be the probability of that first digit. All right, so I think that's, yeah, so let's look here. Yeah, okay, so I think that first one is 9. I'm sorry, it's let's see, 9, 8 is 7. I think that first number is 7. So let's go ahead and create a new cell here. I want to make it a lot easier to look at than to do what I had to do just to figure that out. Let's print our predictions as number labels for the first 4 images. All right, so to do that, let's type print. We're going to use numpy, so np.argmax. So it's going to give us the maximum value from predictions on axis equal to 1. So that's the horizontal axis. And then we're going to print the actual results as well. So I want to, maybe I put that in comments here, print the actual results, or the actual, how about labels? All right, so print y underscore test, and we want the first 4 labels. All right, and let's see how well our model did here. Okay, so like I said, that first image was the image of a 7. Looks like the second one is 2, 1, and 0. So this is what our model predicted, and it actually matches what the actual values of the labels are for the first 4 digits as well. So that's pretty cool. You know what? Let's just have some fun here, and let's just show the first 4 images in the test data set for fun. All right, so let's create a new cell. And here we're going to show the first 4 images as pictures. And to do that, we're going to use a for loop. So for I in range 0 to, I think to 4, it could be 5, I always forget here. Let's see, image equals x underscore test at that position. And then image is going to equal a numpy array. So we have to transform the data back to what it was before, basically. So image d type is going to equal, it's going to be a float. Okay, and I'll create another variable and call it pixels, and I'm going to set it equal to image dot reshape. So we're going to reshape our image again, and we're going to make them 28 by 28. And I need to make that like this here, use tuples. Okay. And then plt.imShow. So now we're going to show the images, so pixels, and we want the C map to be gray. All right, and then let's show the image. Okay. So, and actually it's 5 here. I don't believe it's inclusive. So let's go ahead and run this. So 7, 2, 1, 0, 4. Okay, 1, 2, 3, 4, 5. Oh, sorry. So I am showing the first 5. So let's make this 4. So it is 4 like I thought before. And so now we see the images basically in the grayscale. So we see 7, 2, 1, 0, just like what the labels show here. Okay. So that's basically it, guys. I hope you enjoyed this video. Please leave any questions you have in the comment section. Don't forget to hit that like button, that subscribe button if you did enjoy this video. And if you found this video helpful, please share it. Maybe others will find it helpful as well. And as always, guys, thanks for watching, and I will see you all in the next video.